Now let us dive deeper into our lesson. Okay, so here we have another form of factorization where we have the difference of two squares. Now the difference of two squares comes in the form of a squared minus b squared. So the key thing is minus because as we have the term the difference, it means that difference, when you hear about difference in mathematics, we're talking about subtraction. So a squared minus b squared. And literally this form is one of the easiest forms in algebra. So in terms of factorization, the first thing we're going to have is that we're just going to have a pair of double brackets. So 1 and 2. So a pair of double brackets, one being positive, one being a negative. So one being a positive, one being a negative. All that we're going to do now is that since a squared times a, or a, sorry, since a times a is a squared, we're just going to have a here and we're going to have a there. It's the same thing for the b. We're just going to have b there and b there. And that literally is my solution. So it might look very like, I mean, that's very simple and straightforward. I mean, there's no catch to it. If we were to really work that out, say a times a, that's a squared, and a times b. So let me just use the arrow so we can see what we're doing. This is a negative b, so that's negative ab right there. And then this positive b now is going to times this a, so it's going to give us positive ab. And then this b now is going to multiply this negative b right there. So b times b is negative b squared. And if you look carefully, is that these two literally, so negative AB is going to cancel out by this positive AB. And all that we're left with is A squared minus B squared. So that is as simple as it gets. I mean, there's no catch to it. Let us look at another, let us look at another example. All right, so let's look at this example right here. So we have 9a squared minus 121b squared. So the first thing that I said is that we're going to have our pair of double brackets. So that's the first step. The next thing now is that we have one positive and one being a negative. So having one being positive and one being a negative, we're just going to look at our first thing that we like to look at is our coefficient. So where we have 9, we can find the square root of 9, which gives us 3. That's 3 threes is 9. So what you will find out is that as the term squares, is that both my coefficient and my variable are being squared. They are squared numbers. So 9 is a squared number and 121 is a squared number. So if I even have like a scenario where we have 3 squared, right? If I had 3 squared and a squared minus, this one is actually 11 squared and b squared right there. In a scenario as this, we already know that the 3 is being squared, so we'll just take out the 3. So we have our double brackets, one being a positive, one being a negative, just the same. And then this 3 now would literally be like right there, right? Just like that. So having that now 3 plus, so this would be a right there, and this would be b. Wait, just making sure of something. Right, that would be b right there. So uh, sorry about that. So if we were to have it with 11 squared and b squared, like if we were to have it all written as this, we could have our pair of double brackets. Pair of double brackets. And then now this 3 we would know already that that is going to be 3. And since the 3 and the a goes together, we have 3a. So as we know as well is that our double brackets, one is going to be positive, one is going to be negative, right? So this 11 now, we're just going to put it here. Just going to make some space. And then we would have that b. It's the same thing that we're going to have here. 3a minus 11b. Minus 11b. Right? So I just want you to have the idea that the numbers have to be squared numbers. And that is just what I want to say. So where we have now the 3 being here, I should have said that yes, we have the 3. So the next thing that we have to do now is that we have a squared. So we're just going to write our a here, and we also going to write the a here. Since a times a is a squared. Now we have 121, the square root of 121. What's the square root of 121? The square root of 121 is equals to 11. So we're just going to have our 11 here. We're going to also have it there. So looking at it now, we have 121b. So b times b is b squared. So we have to have b on both sides. Right? So that literally is our solution. 3a plus 11b in one bracket, and in another bracket 3a minus 11b. So if we were to really multiply these things and look at it like that, this would actually be 9a squared. Actually put x, 9a squared, right? And then this now 3a times negative 11 would be, this would actually be negative 33ab. And then 11 times positive 3a is going to be 33ab, right? Then 11 now is going to also multiply this 11, but it's going to be a positive times a negative, so it's going to be a negative. 11 times 11 is 121. b times b is b squared. So as we can see here again, these two are going to be cancelled out. So I'm left with 9a squared minus 121b squared. So that is how you do the difference of two squares. As I say, it's a very straightforward way of factorizing. There's nothing technical in it. It's just very much as straightforward. Just always remember that these two terms, or the coefficient, or the terms, then the terms between both. So this is one term, and this is another term, right? Just understand that what is there are squared numbers. Everything is being squared. That's just the main thing to bear in mind. If you are asking in your minds at this point, what if the both of them are not being squared, then you revert to the way of factorizing how we started out, using the basic terms when we're just factorizing two terms. So, but the only way to do the difference of two squares, the only format the difference of two squares comes in is a squared minus b squared. If you're given a situation where you have, let's say 2 and b squared minus a squared, for argument's sake, there's literally nothing that can be done right here. Literally nothing. I mean, if I had 3, for example, there's nothing that can be taken out there. That is just it. We can't do it. That cannot be simplified further. So the main thing is that these two numbers right here must be squared numbers. 2 times 2 is 4, so 4 is a squared number, and this 9 is also a squared number. So everything here must be a squared number in order to do our difference of two squares.